will be recording. So now we'll do it some more questions based on eliminating arbitrary constant in some of the cases, and in some of the cases eliminating arbitrary function.
Okay.
Okay. कॉल आ रहा देखो. So the question is, suppose that here only z is equal to ax cube plus by cube. Okay, now. So can you tell me what are the arbitrary constants here?
A and B.
Very good. Because x and y are variables here, then arbitrary constant is x and y only. Z is a function containing these two variables x and y. So the process of eliminating arbitrary constant, step number 1 is differentiating. We assume this is equation number 1. Okay. Differentiating equation number 1 with respect to x. Differentiating equation number 1 with respect to x. So this is becomes dou by dou x of z is equal to, we see here a is a constant, right? Dou by
Yes.
x of x cube plus, once again, can you tell me the second part answer with respect to x?
Okay. By, sorry, it will be 0.
Yes, of course it is 0, which is equal to a into, now x cube with respect to x is what? 3x square. You know that? You know this answer? Or shall I?
Yeah, I know that.
Yes, and this value, yesterday I said this is the nothing but p value, right?
Yeah.
Now if I want to make it a as a subject, then it is becomes p by 3x square is the value of a. Understood?
Yeah.
This is the value of a. Now differentiate equation number 1. Now what we have to do it in this case with respect to y. Now I want your answer, right? Tell me.
Okay.
Dou
z by dou y equals to
z by dou y is equals to b
0 plus
0, no need to write. 0, no need to write. Dou by dou y of y cube.
cube. So
this is nothing but q is equal to b into
b 3y square.
If I want to make it b as a subject, then q by 3y square is the value of b. Got it? A and b clearly?
Yeah.
So now we have to substitute a and b in equation number 1. Substitute a and b in 1. Substitute a and b in equation number 1. So equation number 1 becomes z is equal to a is this one, p by what? 3x square into x cube is there. X cube is there as it is, plus b value. B value is what? Q by
3y square y cube.
Y. Now look at one term with this cancel like this, x cube, and one term is cancelled, a cube, and this y square term is cancelled. Then what is left of? Z is
equals to p by 3. P by 3 into x.
P by 3x, right?
Yeah, plus q by
sorry, not p by 3x, px by 3. X is left here in the numerator, right? Denominator का x cancel हो गया completely, but numerator is there.
Yeah. Yeah.
And this is what qy by 3 is the required PDE. आप लिख लेना last में is the required PDE is the required partial differential equation, which is the
Yeah.
end of this problem. Moving to the second question. Today, inshallah, we will try to finish this arbitrary constant and arbitrary function, how to eliminate and how to form a differential equation, partial differential equation. Second question is x minus a whole square plus y minus b whole square is equal to z square into cot square alpha. Cot square alpha. Now you tell me the process. Solution. Step number 1 is given. Here I forget to write the given. Here we write it. X minus a whole square plus y minus b whole square. Y minus b whole square is equal to z square into cot square of alpha. Call it as equation number 1. Right? Now we start our work. What is our work? Differentiating equation number 1 with respect to x, and don't forget to write partially. Okay? Partially.
Yeah.
Can you tell me the answer now? We did this
So
type
we
of
will
question yesterday also. X power n,
be
x power n form n x power n minus 1, that is 2 minus 1. We need not to write, but
into
there is a inner function dou by dou
yeah.
x of x minus a plus, we don't want to write this 0, forget about it. Now z is a function of these two variable x and y. So the derivative of z square is nothing but 2z into
Yeah.
the differentiation of z partially with respect to x as it is. And this cot square alpha is a constant. And it is the multiplication, so write down as it is. Now what happened here is these two cancelling with these two. And we know this value. Dou z by dou x value is p. You know already?
Yeah. Can we write do as D as well?
No, dou itself represent that we are doing partially. D means
Okay.
ordinary.
Because in my college, my sir was writing D somewhere and do somewhere, so I got.
You should not be confused, please. आप हमेशा से याद रखिए, wherever I am writing D, it represent the ordinary differential equation, and wherever I am writing dou, it is representing the partial differentiation. Especially in these two units, we should write dou only. Okay, dou only. And now this arrow will go to this part, and that part answer is 1 is equal to, entirely the meaning will become different. Otherwise, if I am writing D, the value of this
Okay.
is nothing but P here, dou Z by dou X. If I am writing
Yeah.
dz by dx, then how it is becomes P? Cot square alpha, right?
Yeah.
Can you give me a small favor? Do one thing, which book your sir is following, take a pic of that book. Please send it to me. I'll just check it.
Okay.
Right? So
Yeah.
x minus a
Actually,
into zp cot square alpha is over. Any doubt?
yes.
No doubt?
No, no doubt.
Now, second part. Differentiate this equation number 1 again with respect to y partially. With respect to y partially. Can you tell me the answer now? I want to write direct answer. 2 times of y minus b.
Uh,
Right
2
now,
times of y minus b into 1
inner
equals to,
function, no need to write, neglect, equals to
yeah,
2
okay.
times of z
2 times of
into
z q.
dou by dou y of z right, into cot square alpha, right? Once again, the same story. What's the story? 2 and 2 will be cancelled, and this value is nothing but q, right? So this is y minus b is equal to, this is q into cot square alpha. This is taken as equation number 3. Now we have to use equation number 2 and 3 in equation number 1 using 2 and 3 in 1 to eliminate the arbitrary constant. So what happened, you see, if I'm substituting x minus a value, I want x minus a whole square value. So better to square it here also. Zp cot, let me reduce one more step. Z square p square cot square alpha whole square. Is that okay? Plus.
Okay.
Then here also, if you square, sorry, we forget to write here that. Then it is also, if I want to square it, z square, because I want y minus b whole square value now. Z square, q square, cot square alpha, and this part also whole square is equal to z square into cot square of alpha. So you can see entire this function, we can take z square common.
Yes.
Means it is p square cot square alpha whole square cot square alpha whole square plus q square cot square alpha whole square is equal to z square into cot square alpha. Cot square alpha. First of all, I want to cancel z square on both sides. We can do it at a time also, but do it one by one, it is better. Now you can see in these two also we can take cot square alpha whole square common. P square plus q square left out. If I am taking what common? Cot square alpha whole square. That whole square can also be written as cot square alpha into cot square alpha. Can I write like this? Whole to the power of 2 now. Here cot square alpha square I am taking common into here cot square alpha must be as it is. Why? Because I want to cancel these two terms also. This multiple terms if you go that side. So I'm writing the system is will be here. P square plus q square is equal to, if this multiple terms will go that side, it is becomes 1 by cot square alpha. But we know that 1 by cot, what is 1 by cot?
Tan square.
Very good. P square plus q square is equal to 1 by cot is tan square alpha. Now if you see the answer, we have no more a and b available. Is there? Is there? Here also a and b is not there in our answer. Required PDE not containing any arbitrary constant. In this also it should not contain any arbitrary constant. Like these type of questions we have to discuss. Okay. Right. Today we are going to learn an important formula also. How to eliminate a arbitrary function. So take next question. Next page I'll take. Okay. The question is, form a partial differential equation by eliminating arbitrary constant from z is equal to, it's an important question, y square plus 2f into 1 by x 1 by x plus log y. 1 by x plus log y. This is the question. We have to eliminate this arbitrary function, this function f value, from this differential equation and form a partial differential equation. So let me start our work. Solution. Step number 1 will be given z is equal to you see what's the difference between the previous questions and this question. In the previous question we have to eliminate this arbitrary constant a and b, and now in this question you see we don't have any a and b. F is there,
Yeah.
and I want to eliminate f. Look at the question, sometimes it is not going to mention. We have to understand that y square
Okay.
plus 2f into 1 by x plus log y plus log y.
Okay.
This is taken as equation number 1. Now the regular work. What's the regular work? Differentiating this value of z partially with respect to x. I don't want to mention this dou itself represents that we are doing partially. With respect to x means y is a constant, plus constant becomes 0, 2 as it is. What is the derivative of this function? Derivative of function is f dash, right? F of x, differentiation of f
Okay.
of x is f dash of x. Similarly, differentiation of f is f dash, and the inner function will be as it is, log y as it is, and we have to do it inner function for this. It means dou by dou x of inner function. Inner function is what? 1 by x
1 by x plus log.
log y. You
So
understand this step? You understand
yeah, I
this?
understood.
Yes.
Yeah.
This value is nothing but p. P is equal to 2 into f dash of 1 by x plus log y, 1 by x plus log y, and into this arrow will go to this term only. Right now, 1
Yeah.
by x, 1 by x only possible. Derivative of 1 by x only possible, and rest will become a constant, become 0. This
Cons.
arrow will go to this term only.
Yeah, yeah. Yeah. That
So derivative of 1 by x is what? Minus 1 by x.
minus 1 by x square.
This will be close. Constant term I am not writing. Okay.
Okay.
Okay. So let us go for another differentiation, that is differentiation of z partially with respect to y is equal to, now you see y square differentiation with respect to y becomes 2y, correct?
Yeah.
Plus 2 into derivative of f is nothing but f dash of 1 by x plus log y into dou y of inner function, that is 1 by x plus
By x plus log.
log y. Close it. Now this is equal to q is equal to 2y plus 2 times of f dash of 1 by x plus log y by x plus log y into, now you tell me where this arrow will go. This arrow
Log
will
y.
go to this function. Their
Yeah.
corresponding function only it will go.
Yeah. So it
So
will be
that,
1 by y.
yes, it will be 1 by y. 1 by y. Okay. Now what happened here is, what I'm going to do it. You see, I want to get the value of this one. Actually, this value I want to replace. 2 times
Yeah.
of f dash of 1 by x plus log y value I will take from here. So how to get it? This x square we multiply that side, cross multiply. It is px square. Okay, and
Yeah.
that
Yeah.
minus sign also we multiply that side, is equal to 2 times of f dash of 1 by x plus log y. Okay, 1 by x plus log y, called it as equation number 2 and called it as equation number 3. So what you will write it here? Using, here continue, using 2 in 3. Right now, using 2 in 3. So now see, q is equal to, we have q, it is equal to as it is, even though 2y also as it is. Now this value, 2 times of f dash of 1 by x plus log y value is what? Tell me. Tell me what?
2
Minus px square, right?
minus, so yeah,
Minus px square. This one close it into 1 by y also as it is. Right? This y,
yeah,
this y we can cancel it. Q is equals to minus 2px square. Oh, sorry, we forget to write 2y also. We have one more 2y also here left. You see, in equation number 3, one more 2y is there. 2y as it is. This 2y as it is. This one, this 2y. Plus now this value will be available here. That is what? Minus px square into 1 by y. Okay, so to simplify further, multiply y on both sides. Multiply y on both sides. So if you multiply y on both sides, how it is becomes? Qy is equal to, tell me what happened? 2y square minus px square. Am I correct?
yeah,
One more step, if you want to write, you can write it. Qy plus px square is equal to 2y square is your required PDE. Now you see in our PDE, we don't have any function value. F term is not there.
yes.
That is your answer. So let us move on to another question based on the same concept, eliminating arbitrary function. Now the question is, form a partial differential equation by eliminating arbitrary constant from z is equal to f of x square minus y square. F of x square minus y square. So we can start writing the solution. Solution. First step is given, z is equal to f of x square minus y square. We take this in equation number 1. Now start our regular work, that is differentiating equation number 1 with respect to x partially. Dou z by dou x is equal to. Now you understand, now we will write direct answer. F dash of x square minus y square into inner function is 2x directly. You understand the system?
Yeah.
Yes. So then we say that p is equal to f dash of x square minus y square into 2x. Right?
Yeah.
Call it as equation number 2. Similarly, we can differentiate equation number 1 partially with respect to y, and we write the direct answer. Dou z by dou y is equal to, to differentiate partially with respect to y, it is f dash of x square minus y square into function of function, that inner function is minus 2y. Correct?
Yeah. Can trigonometric functions be eliminated?
Yeah, so that type of question is also there. Trigonometric function
Yeah.
is also there.
Because I remember last time in M2 or M1, I think I got a trigonometric function for arbitrary constants to be eliminated.
That type of question is also there. We are going one by one slowly.
Okay.
Minus 2y. So remember Jacobian concept? Jacobian.
Yeah,
Okay.
Jacobian method.
Now next concept is Jacobian only. We have to use Jacobian formula, Jacobian concept to eliminate the arbitrary function. I'll give you the example also for that. Equation number 3. So to eliminate arbitrary function, what I am doing here is I am dividing 2 with 3. So if I am dividing 2, equation number 2, right side value is p. Here right side value is q is equal to, here we have f dash of x square minus y square into 2x, and this is divided by, this is f dash of x square minus y square into minus 2y. Now look at how many terms are cancelled. This 2 cancelling with this 2, this entire value will be cancelled, right?
Yes.
P by q is equal to minus x by y left.
But why are we dividing equation 2 and 3?
Our target is to eliminate the function value. That's it. No more f required. या तो you
Okay.
can go for by substitution like this previous problem we did substitution, or else we can divide anything, but we have to eliminate. So it is what
Yeah.
py is equal to minus qx, or we can also say that qx plus py is equal to 0 is the required PDE, which does not contain any function value. Okay.
Yeah.
So this type of questions you will get, and most important question which maybe you will get in your exam, that questions I will tell you along with the formula we have discussed. Okay. Let me take the next page. So now how the questions will come to eliminate arbitrary function. Sometimes what happened? Sometimes what happened? The question will be like this: f of u comma v is equal to 0. In this form means what? A function value will be given, and there are two more functions which are also again the function of u and v. Like example, for example, f of, suppose the question is like this: x square plus y square plus z square, comma, comma, z square minus 2xy. You may come across the situation like that. It is asking to eliminate the arbitrary function once again from this. Now how to do it?
Yeah.
Differentiating partially with respect to x is not possible here because comma is there. Comma वाले
Yeah.
function को अपन differentiate नहीं कर सकते. So in that case, we have to use a special formula that is called a Jacobian formula, and the formula will be here. Very interesting and very important. Can you read this one? How to read?
2
If you
of u comma v.
no, if you are aware about the engineering formula, we can read this one as Jacobian of uv with respect to yz.
Yeah.
Okay, tell me what is the advantage of Jacobian? Where we are using Jacobian?
For the terms with comma.
I will tell you. If you want to differentiate two functions with respect to two functions,
Okay.
that case we have to use Jacobi. This is a simple example. Like this is a simple example. What is the meaning of this? The meaning of this is differentiating this value of y with respect to this function x.
Yeah.
Here one function, here one function. So this is called ODE, ordinary differential equation. If you have more than one variable, more than one, two bhi ho sakta, maybe it is three also. That case we have to use Jacobian. Jacobian is the relation between two functions with respect to two functions. The derivative of
Yeah.
more than one function with respect to more than one function. In that case, we have to use Jacobian. यहाँ पे दो से ज़्यादा function है, so then we are using. So formalize. This is the formula. Very important formula. If I'll do it, the questions based on these formulas, then elimination of arbitrary constants concept will be over. Then we can form a differential equation by direct integration method.
Okay.
Jacobian of uv with respect to x z into q is equal to Jacobian of uv with respect to xy. Okay. Now, how to get these values also, that also I'll tell you. How to expand those values means how to find out the value of Jacobian of uv with respect to yz. I will tell you the trick to remember the formula. To expand
Okay.
this formula, how to get, it's a determinant of 2 by 2 matrix. Now, how the values will, how to write the values? Dou by dou y, dou by dou z, dou by dou y, dou by dou z. And here in the first row, u, u, v, v. It is the value of first one. Second one,
Yeah.
Jacobian of uv with respect to xz. Once again, we can write this one with the logic. The logic is dou by dou x, dou by dou z, dou by dou x, dou by dou z. Now again, u, v, v. And we have one more formula, that is Jacobian of uv with respect to xy. It is equal to, under the 2 by 2 matrix, under the determinant of dou by dou x, dou by dou y, dou by dou x, dou by dou y, u, v, v. That's it. That we have to substitute the values and find out the determinant. You will get your answer. Okay. So whenever you have more than two functions, then we have to use the Jacobian formula. We use this formula to solve this type of questions. If we finish this concept, then we have formation of differential equation by eliminating arbitrary constant and function is over. We can go direct integration method. Acha, you remember in your faculty is using any Lagrange's form?
Yeah. Lagrange's.
Charpit methods?
Yeah.
Okay. So we'll be continuing this one. If possible now, you just send the pic of that photo of that textbook which your faculty is going to be followed. Right.
Yeah. Okay.
So any doubt in this today's section? Oh, I am going to take only one session daily. 1 hour class is not possible because it's too late. But anyhow, I will finish the syllabus.
Okay.
Don't worry about the syllabus. It's up to me. Sometimes I'll take 2 sessions also if I'm free. Okay.
Okay. So
I'll take
Saturdays and Sundays, you will take 2 sessions, right?
Yes, we'll take inshallah. We'll take 2 sessions. Saturdays and Sundays.
Okay.
Inshallah. Okay. Any doubt in today's discussion?
No.
Okay. This PDF and this recording will be sent it to you. Okay. You can see
Okay.
the recording later on. And still, if you want to solve any question which you feel that it should be solved in the class, you just send me that photo of that question or send me that question through WhatsApp so that we can discuss in our sessions. Any questions
Yeah.
related to this topic? Okay.
Okay.
So
Okay.
this class will be going to finish within 2 minutes. So thank you. Have a nice day. Right.
Yes. Thank you.